Any questions? And test two, for those that came in late, test two should be back and graded. And I know I'm a little bit behind on grading other things, but I will get those things graded shortly as well. It should be a grade-a-thon here pretty shortly. Continuing grade-a-thon 4.0.
Okay, Professor, I was looking at the test that you were talking. So, I mean, I guess we'll get back. Can I get back with you again later so you can give me some update onto this?
Yeah, I mean, if you want to come by during my office hours, I can also go down by. I can go through stuff during office hours, right?
All right. Yeah, I did pretty good though. I mean, you know, I did pretty good.
Yeah. I mean, like,
wow, I did good.
Yeah, I mean, ideally you want to be making at least a 70, right? Probably.
Yeah.
But anything like, as long as you're making like a 50 is probably something you can save yourself from. If you're making 40s and 30s and 20s and stuff like that, like, you're making some bad decisions.
No, this was this is over 60. I said this was over 60.
Yeah, I mean that's all right. Ideally, you want to make at least a 70. 70 is passing for the class, right? 80 is a B, 90 is a A.
Okay. So I got a D, but still, I did better than what I thought I would. That's for sure.
Yeah, and with this class, like, I don't know, but like people do different on different sections of this class. Basically what I'm going to say. I wouldn't be surprised if some of the test grades, I hadn't really looked at them extensively and compared them. I wouldn't be surprised if a lot of them went up from the first test, because the first test was a lot of logic, and people don't always do that. It's so hot in logic. So typically in a math class, like, you have some sort of stuff that really, really kind of builds on itself. And in this class, you don't get that quite as much, right? It kind of jumps from one topic to another a little bit more so.
I actually have a quick question regarding that. I noticed for the upcoming chapter, I know I'm getting ahead of myself, but for the upcoming chapter, I think we're going to chapter 7 and then we're going back down to chapter 5. Is that going to be another one of those cases where we're going like when we went to chapter 10 and then we kind of did like revisited geometry in the following weeks?
I'm trying to think what those are. I think those are the basics, starting the statistics.
I think it's like probability.
Probability and statistics. Yeah. I think it's based in that. I don't have to look at what 7 and 5 are. I couldn't tell you off the top.
Just so I know like how much extra time to kind of like put aside for potentially skipping ahead of something.
Yeah, I might get, I don't know. My undergrad minor was in statistics, so I took probably too many statistics classes. But there's a guy that was known for like factoring stuff. His name was Cardano, and he was a guy who did a lot of probability theory stuff, and he was a big time gambler. I remember having to write a paper over Tartaglia, who was like, there's always like these arch nemesis in math. It's kind of really weird. They kind of compete against each other. But that was sort of like the history of it. There's really kind of a weird history of how professors got their like sort of position. They would publicly debate each other in like math problems. They would do these like public debates, like dance offs or something. I don't know, not dance off, but a math off, right? Is like pretty much equally as ridiculous. And so your entire position at that university and as a professor was like dependent upon being able to outperform people that could like challenge you, or being able to outperform people. And so for the longest time, it was in your interest not to publish things. It's like almost the antithesis of what it is now, like where they try to get you just to publish things all the time. And so like there's a lot of sort of math knowledge that like was kind of created, and we don't really know who did it first. And that's one of those examples they both had ways of factoring like cubics or something kind of weird. But yeah, they both they fought each other basically.
Cool.
Yeah, y'all are gonna have to do. I'm gonna give y'all a project pretty soon, but I could basically tell you what the project is. I want you to go study something in math, something weird, something fun, whatever you want, basically. I'm not gonna have a lot of limits on like what you can do. It just has to be like math related in some way. It could be a mathematician, and basically the assignment's gonna be to write 3 pages with 3 credible resources. I don't think that's too long. It's pretty reasonable for a college paper.
That's cool. Now that I can do.
I'm gonna have to I'll formalize it and I'll put it
This
up on
I
the web.
might not try to do, but that I definitely can do.
Yeah, I will formalize it and put it up on the website and stuff pretty soon. That's what I plan to do. I wrote myself a note. But yeah, y'all have to do a project in here. So that's basically what your project's going to be is to research a topic that you like. And there's a lot of weird stuff like that in math and math history. The other thing is like the Newton Leibniz controversy, right? They butted heads for a while to argue who developed calculus, right? It was during the Black Plague, and they like sent everyone home, and like Newton supposedly developed it, or he gets a lot of credit for developing it, but like a lot of that is probably due to his like association with the Royal Society, I think is what they call themselves. He was like he was in leagues with some pretty prestigious people, basically, and
I thought the calculus part, abacus or whatever it was called, abacus was Chinese counting. Abacus. Do you know what I'm speaking
abacus,
about?
like an abacus.
Yes, abacus. Yes.
That's
yes. I thought that's where the ninja originated.
That's like a calculator, like a
calculator.
So brief recap. Well, we can do a brief recap of math history if you want. There's like the Babylonians, right? Who what was it? Yeah, I'm trying to think of their name now. The Sumerians, that's what they are, I believe. In the Mesopotamia area, they started with like, that's some of the first like writing stuff that we know with the cuneiforms and the stone clay. They would bake it into stone clay. So a lot of the history like behind math is like, there is probably some history there in the Eastern world, but we actually don't know a lot about like Eastern math because a lot of it was written on stuff like bamboo and things of that nature. And bamboo doesn't last. So a lot of the stuff we know comes from like the Babylonians in the Mesopotamia area sort of thing. And they wrote their stuff on clay, little cuneiform tablets. And so that's sort of the first stuff we have with like numbers. Or some of the earliest stuff. There's always sort of like a social sort of epicenter of like development that's happening, right? There's basically got to be a whole society backing you to be able to like sit around and think about this stupid stuff all day long. And so really one of the first societies was the Greeks, right? And the Greeks have a lot of like geometric stuff that we take from the Greeks. Pythagoras theorem. There was a whole cult that like Pythagoras started. They believed in like crazy numerology stuff. There are so many Greeks you can talk about, but was it Eudoxus? There's so many of them I can't remember. A lot of them knew that wasn't a heliocentric. It was a heliocentric universe, not a Earth-centered universe, right? There was a ancient Greek that like actually estimated the circumference of the Earth. I believe it was Eudoxus. I could be wrong.
Under that group you were talking about with the numbers, wasn't that the beginning of when symbolism of the numbers come out?
Probably when they started doing things with their little cuneiform little thing. You get a little thing and you dip it in your little clay and you leave a little mark.
No, I was thinking more so like finding reference to like completion, what number represents completion, and what number represents the half, or I just like the symbolism of it.
I don't know. I was
Yeah.
onto the Greeks. So if we want to talk about Greeks, they did a lot of advancements in geometry, right? And a lot of things. I don't know. Geometry is kind of like it's just a sloppy way to prove things, to be honest, right? Like you can really deceive yourself with geometry. The infinite candy bar example. If you ever look that up or Google it, just like a little bit in a slope can totally throw you off with proving things, right? It's not a very tried and true way to sort of like get to things. But we have next algebra. Where's algebra come from?
Algebra, I believe, is also, wait, no, there's like Sumerian and Egyptian algebra too, so, or Mesopotamian algebra.
Algebra like didn't really come about until after Mesopotamia, after the Greeks.
Really?
Yeah.
Huh.
Where does that prefix come from? AL.
Wait, yeah, wasn't algebra a thing in the Islamic world, or yeah,
Baghdad.
Yeah,
Yep.
yeah.
So this guy, where's he at? Can I see him? See it. So Al-Jabbar is the guy's name.
Yeah.
I don't think maybe this is the guy's name. This is it. This is the guy. Sorry, wrong guy, probably. So Al-Khwarizmi is where we're getting algorithm from. Don't ask me how. Somehow people don't know how to speak right. I probably totally butchered his name when I said it anyway. But his name is where we get algorithm from. His book that he wrote was Al-Jabbar. Where is it out? I can't see it. It's Aljabarr, something like that. It's somewhere in here. Do they got a little picture of him? Guy looks like a total. He looks pretty wizardly, right? Okay.
They made money out of this guy, huh? They turned his a stamp. Oh, okay, I see stamp. Wow.
Yeah, and so we have like the Middle Eastern. So we get all our numerals actually come from like the Middle Eastern influence. Where is my stop screen? There you are. So all our numerals come from the Middle Eastern influence. The 1, 2, 3, all the symbols we use for our numbers. After that, I'm trying to think of where the epicenters were. For a while, it was in like Austria, Germany. If you look at the Austrian circle, for a while, like, and this was like pre-1930s. Around the 1930s, some other stuff happened, and it really went downhill in the Austria, Germany area. But there's a lot of really prestigious stuff happening in logic and in math. If you look at like Bertrand Russell and Whitehead and all those guys, what they were trying to do is they were trying to axiomatize the entire system of like algebra, which is like basically you get all the rules down, all the basic self-evident rules, right? There's another guy that comes along, and if this sounds crazy, it probably is. Gödel, Godel, with umlauts over the O. And he proved that you actually cannot do that. You trade completeness for consistency. So a system's consistent if it doesn't contradict itself. It's complete if you can list everything. So there's like a trade. If you want it to complete itself, you're going to get a contradiction in there somewhere. So it's a really weird thing, and they teach entire courses over it. So I definitely don't expect anybody to understand it just off the top. But at least you've heard it once, right? But it means we can always find something new to prove in math. Is actually like one of the consequences of it. There's always something new to prove. At least that's kind of how I look at it. And so after like Austria and Germany became an epicenter, another epicenter after that was what? There was a bridge on the Cam River where everyone crossed across the river, and they built a college there, and they called it Cambridge. There was a spot in the river where they forded it with the oxes, and they built a college there, that was a common spot where they forded it, and they called it Oxford. And so for a while it was England, and Oxford and Cambridge were pretty prestigious and produced a lot of work. And now it's kind of the US, but the US is kind of fading and being the main producer of work. I don't know, of math theories, right? It's becoming, I think, more global, as I think it's getting spread all around, I think. The other thing is they don't give away Nobel Peace Prizes in math. I don't know if you realize that. Nobel Prizes are for applied fields. Does anybody know what they give away in math? It's called the Fields Medal. there was a it's so horribly
So can I ask what Einstein received?
He received Nobel, I'm pretty sure, because he's a physicist and he's an applied physicist and had applications.
Is that so
wrong.
that doesn't consider math being the physicist? No.
No, it's an application. You're applying it to the physical world. All right, so I think I spent enough time talking about things, but there's some horrible social dynamics happening in math. But one of the first female Fields medalists did win it like 5 years ago, probably, or so now. It wasn't that long ago. But her name was Miriam Mierzinski, something like that, something along those lines. Miriam. Okay, so we have all our formulas on page 1, but here we go. Let's get started on this and do this. What's Chuck up to? The following table shows expenses and income for Chuck. Determine his net monthly cash flow. Assume salaries are after taxes, and 1 month is 4 weeks. So if we're paying $240 a week, or we're making $240 a week. Sorry, wrong way. Am I multiplying or dividing that? And what number am I going to multiply or divide that by to get it to a monthly expense?
Multiplied by 4.
I'm multiplying this by 4. I'm getting this 4 times. I'm getting $8,000 a year. Am I dividing or multiplying that?
Dividing.
By
12.
12 months in a year. Same thing with the 1,000. By 12. What am I doing? 240 by 4. I'm doing 8,000 divided by 12. Should I do this? How many different pieces should I do this in? 1,000 divided by 12. I think this is going to give me what, 1710 income?
Yes, altogether.
And then I want to do my expenses. So if I'm getting $975 a month, my monthly expense for $975 is $975. I'm doing $120 a week for groceries, so I'm doing $120. And I got to multiply that by 4 to get it up to the monthly. I got to do $77.50 and divide that by what, 12? So I think these approaches are kind of all the same, right? If I'm doing weeks, I'm going to multiply by 4. If this says per year, I got to divide by 12 to get it to the month. So this was coming from chapter 4A. Can we convert things to monthly expenses? If it's in a monthly expense, I ain't got to do nothing to it. So if we do 975, we add 120 by 4. And I add all these things. I divide before I add things, and I multiply before I add things. What does this give me? 230, 90, 83.
Right.
23, 90, 83 cents. And these are all my expenses. If I want to know my net flow,
The minus.
you got to do this in the right way. So it is income minus expenses. So you got to put the first one, you got to put your income first. So make sure you don't swap your numbers or do something silly like that. What was it, 1710? And I'm going to subtract 2390.83.
That'll be a negative 680.83.
Minus 683.
I did it
Or
right.
you could tell me a loss of 680.83 cents.
All right.
Some way you got to either put a negative or you got to, right? You got to indicate it somehow. Okay. And so I believe this was also from the first chapter, 4A. If you could enroll in a 15-week, three credit college course, which would require 12 hours per week of your time and cost $500 per credit hour in tuition and require a textbook that costs $120. Alternatively, one could work a part-time job that pays $9.75 per hour. What is the net cost of the class? How much could one make if they worked a part-time job for the same amount of time that was dedicated to the class? Okay, so how much is the class? How much is the class costing? The net cost. Class by itself.
$1,500.
Yeah, we're doing $500, and we're doing that by 3 credit hours. 500 per credit hour. And then we also have to buy a textbook. Make it what, 1620? And how much could you make if you are working a part-time job for the same amount of time? So how much time are we doing in this class? We're doing what, 15 weeks?
Yeah, 12 hours per week for 15 weeks, so 180.
And if we do what? 180 hours, how much could we make on the job doing that?
1755. Well, 1,755.
Yeah, we have to multiply it by the rate. So 1755. What do they call it in the book? Like miscost or something? Wasn't there something they asked like that? Where they added the two? I don't think I asked it here.
I thought that was net. I thought that's what they meant by net cost.
That is probably what they mean by net cost, maybe. I thought that's what they said in the book. Let's see. Yeah, that's what they want for net cost. They want the 1620 plus the 1755. That's I really should keep this back. I'm messing up on my vocabulary now. The cost of the class by itself should be 1620. If I want to know what I would do with the work, my work would pay me 1755. And if I want the net cost, together the 16 plus the 1755. I forgot for a second. The book like adds these two together for some odd reason. 75. I guess that's what it's like. Not really the way I would think about it, maybe. All right, so is that hopefully making, is it not making anybody questioning where the net cost is coming from? It's coming from both the cost of your class plus how much you would be making working.
Net cost.
Oh man, I gotta sneeze going. You deposit $1,500 into two accounts, one with the simple interest. Ooh, thank you. And the other with compound interest, paid once per year. Both with an annual percentage of 13%. How much would be in each account after 10 years?
1,002 accounts.
All right, so if we take simple interest, what are we taking simple interest on? We're taking 13% interest of what number?
On 1,500.
Of the 1,500. So this is going to give me my interest per year. I don't know how many steps you want to do in this.
All of them.
Okay.
Oh,
0.13 times what, 1,500? So this is giving me 195 each year, right? So if I do this for 10 years, how much money am I going to get?
is it 195
You're doing that 10 times.
times 10? Okay.
Well, we take what we do, multiply it by the number of years. So it's the interest rate times the principal times the number of years. This is giving me my interest. So I started out with what, 1,500, and I'm gaining 1,950 in interest. And they want to know what my accumulated amount is. It's going to be both those things together. So this is my what, simple interest?
Okay, so 1,500.
Yes.
1,500.
All right, so which one of these would you use for your compound interest?
plus 1950.
P times 1 plus APR to the power Y.
This first one, right, is what you should probably use for this problem. So if we're doing this one, and does it say interest paid once per year? That's the same thing as saying, oh, you're being compounded once per year, right?
Mhm.
If they're paying out interest once per year, that's the same thing as it being compounded once per year. Compounding periods are when they figure things up and they pay things out, right? So my A equals P. Picking out the right formula. Compounded once per year, I can use this simpler formula. And now I'm plugging things in. My P is my principal of what? 1,500. I'm doing my 1 plus my APR, which is, I got to convert this to decimal 0.13. And I got to do this to the Y, which should be
10.
10. All right. Just making sure you're on the same page. So 1,500. So we have done a few of these before, but like our PIMDAS has to come in. I have to add these two things together. So if I do 1.13, I get 1.13 as the first step. And make sure you got a calculator that can do some exponents.
1,500.
This gives me some kind of crazy decimal thing. I'm probably gonna let my calculator round.
526.15. 26, 16.
But the amount I should get is what, 591.85, somewhere around there. Were we expecting this thing to be more or less than simple interest?
More.
It definitely should have been more. It definitely was more.
That equals 30,
All right, so you deposit 1775 into 3 different accounts with 12% APR. The first is compounded monthly, the second is compounded daily, and the last is continuously compounded. How much will be in each after 7 years? All right, so we have 3 different things to set up. So the first account says compounded monthly. You might have to go back and look at your formulas. Do we see what formula we need in there?
Oh,
So this is, if it was once per year, we could use this one. We're not going to be able to use this one. We're going to have to go to the one that's a little more complicated.
yeah,
We're
the
going to
NY.
have to use this one for at least that first one, right?
Yeah. See,
Principal times 1 plus. So we want monthly compounding, monthly. My amount is equal to my principal, which is 1775 times 1 plus. I put some parentheses. I guess I got extra parentheses right here now. I want to convert my APR, which is what?
0.12.
Over n, which is now what?
12.
It's 12 for the monthly number I'm doing. And I'm doing to the NY. This is 12 times
7.
7, which is the number of years. All right, I divide 0.12 by 12, it's going to give me 0.01. I do what? 7 times 12, it's going to give me 84.
4. Okay, got that.
So I'm doing 1.01 to the 84th power. It should give me some crazy number like 2.3067. And if I multiply that by 1775,
Okay, so I'm doing something wrong. Oh, I'm supposed to do the parentheses with the exponent first, then the number, correct?
so you're doing 1.01 to the 84th.
Right, you're doing that one first before you. Okay, I got it.
Yeah.
All right, I got it.
And then we multiply 40494 point and what, 43 cents. Okay, so if I compound it monthly, this is what I should get. If I compound it daily, should it be more or less than this?
More.
It should be more. The more times you compound, the more you should get. And now I'm how does that change this formula? Does my principal change?
Instead of the 12, it's 365.
Yep. Instead of 12, there, I have to replace basically 2 numbers in there. It's a similar process. I do 0.12 divided by the 365. It gives me some crazy, really small number. But if I do 365 by 7, it's giving me 2555. So this one you might have to be careful on rounding because we're getting really small numbers here, really large numbers here. But if I do this in my calculator without rounding, it should give you a pretty good idea of how close you are. When I add 1.003 and do it to 2,555 power, I get something like 2.316 in here. And when I multiply this by 1775, I'm getting 4111098.
Professor, what was on the monthly?
The monthly was 4094. So this one is, we predicted it to be more. It's just only a little bit more. It's like $6 more or something.
Okay, that's right.
And what do I do for continuous compounding? That's the last thing that we're doing.
Is the PERT formula?
It is the PERT formula. So it is a different formula entirely. So don't try, I don't know if you're like trying to plug in an in for continuous, you might like freak yourself out. Don't do that. It is A equals P E P R Y. 1775 is still my P. My E is that crazy thing. It's got to be on your calculator somewhere. My APR here is what, 12%? And I multiply my 12% by my Y, which is 7 years. Is that what they said? 7 years. So we probably want to multiply these things together in the exponent to be what, 0.84, e to the 0.84 before we do the 1775. Okay. So if I do 1775 e to the 0.84 in my calculator, it's going to give me something like 4111.55.
So it's like 84. Okay, so it's 12 times 7. It's 84.
Yeah, it's 0.84. It's a decimal.
0.84. Okay. Okay. 0.8. That's what makes it. Okay. Yeah. So okay.
Hey, Professor, where's the E on the calculator?
Okay. So it's usually opposite of the natural log. It is the opposite in the inverse operation of the natural log.
Mine's is right under log.
And you do have to make sure you're doing the lowercase e, because remember the uppercase E is that scientific notation.
So you have to push the second button, right?
So if you hit this one, yes, you have to hit second. So I'm doing 1775. I have to hit second to get to the blue keys. That gives me the E to the 0.84, and I close it, and it should give me my solution.
And you put the parentheses in there too. I noticed that.
I closed it off.
Okay.
It puts the opening parentheses in there for you usually, if you put the E key.
Oh yeah, I see. It does everything. Okay.
You probably don't have to even put the closing parentheses. It'll probably do it even without it. Ooh, that's not what I want. All right, even if I delete this, it'd probably still do the right number. It's not a big deal. It's just like out of habit. I do that because you want to close parentheses off typically when you open them up. It's not a big deal on your calculator, but some programs are really fussy about it. Where's my pen? My pocket. Here we go. Okay. All right. So those are 3 different ways. Is that all they asked? That's all they asked, right? I do it monthly, compound daily, and continuously. Yep. Okay. Any questions about this? So monthly and daily, we kind of do the same. We do the same formula, but when we get to continuous, we have to use something different. If they're nice enough to give us it once per year, we have a special formula for once per year. All right. Your father invested 55.45 into Betamax 35 years ago. You found out that they are worth $5.99 today. What are the total and annual returns for this investment? I don't know why it's all decided to hit me right when I started class.
35 years ago.
How do I find total returns? And this is the thing we've kind of talked about. This is the relative difference. So what does my relative difference look like? Total world. So what do you notice about this thing? He's spending $55 and he's getting what, $6 back?
You lost money.
He lost money, so this thing should definitely be what?
Negative.
Negative. And in order to do that, what we're doing is the new price is 5. The old price is 55.45. If we do that, what do we have to put on bottom?
55.45.
This thing should fill out itself from this guy, right? All right. $5.99 minus 55.45. Was that 49.46?
Yep. 46. Negative 46.
Someone's having a pipeline party outside. That's all I hear playing. Some surfer rock. Okay, so this is negative 0.89 something. 891. Whew. Yeah. Whew. Oh, hold on a second. That is a negative 89.19%. Okay, so this decrease. So we do 89% of like $55. I think we're going to get $5 is what that's telling me. Oh, sorry. No, that'd be the other end of it. 89% of the, what, 55 would give me the $49. Sorry, I said that backwards. 100 minus 89 would give me the 5.
85. So he made half.
So this is definitely going down. This is my total returns. This is what is going down over the total life of this thing. The other thing. Oh man, I can't even believe I gave you a formula for total returns. Look at that. A minus P over B. That's ridiculous. You should know that already. And I guess you ain't gotta memorize it though. Huh? It's just the relative difference of the two things, right?
All right.
Annual return looks like A over P. So annual return is a little bit funky, but it looks like A over P. So I'm doing A, which is the 599. I'm doing the P, which is the 5545. I'm doing the 1 over Y. So how many years do they tell me here? 35. 1 over 35 in the exponent. And then after I get done with all this stuff, then I have to subtract 1. Look at my calculator. I lost it. There we go. All right. So 599. I'm dividing that by what? 5545. If I do 1 over 35, it might be more advantageous to like decimal. Okay. Can y'all hear that like in the background at all? Okay,
No,
probably good.
I'm really not really too much of listening to that. I mean, because my mind is so much into what you're doing.
It's just like my neighbors like playing some music.
I can't hear it.
Yeah, it's like not a lot I can do about it. Besides go and yell and waste more time. But if y'all can't hear it, it's not a big deal. It's just something I have to put up with. It's my distraction, not yours.
Maybe they take requests.
Yeah, mine. So
Yeah,
Wizard
what's
Lou,
up there for you?
I might go join them afterwards. Oh man.
So, Professor, when you did the 135, did you do it like a fraction? I mean, is it a divide or is it a?
Yeah, I would do it as a decimal. Might be easier to put in as a decimal. It all depends what your calculator's like. Like I didn't even put it in as a decimal in mine. I put it in just straight. I put my fraction to
Right.
that fraction. So I didn't do that in my calculator, if I'm being honest. But if you run it to a decimal, it might be easier to input into whatever technology you have. I don't know what you got. But the last
I
step
have the
I have
same-
to do.
Oh no, I have a 30XIS, the same instrument. You seem like you got a little stronger.
The last thing I got to do is subtract it from 1. So this is like 0.9383, and I have to subtract 1. I'm getting somewhere around a minus like 0.0616. And what this is telling me is that I have a minus, and I got to convert this to 6.16%. It's telling me it's going down 6% every year is what this thing is saying.
Six. 6. I gotta make the decimal. So I have to make this decimal percentage, correct? Yeah, I see it. Okay, never mind.
Yeah, so that's your decimal. Move it to percentage. And so it's telling me over the 35 years, each year it's going down by about 6%. Mess this stuff up. What was that 6 by what 35? It's probably a little off. Yeah. Okay. And then this is the same problem, different numbers. You invest 300 in one account, which grew to 500 over 4 years. You invest 200 in another account, which grows to 600 over 10 years, which has a larger total return, which has the larger annual return. So I want to do the total return. Do the annual returns and compare the annual returns. I think that's probably the way to go about this. So I want to do the relative difference from 300 to 500. So I don't want to spend maybe too much time. But I take the difference between 500 and 300 and I divide it by what number?
4.
What? If I want the relative difference, how do I get that?
300.
I gotta divide it by 300 to get my relative difference. And
Oh,
then you gotta multiply and convert to percentage.
yeah, yeah.
The
Jeez.
other guy looks like 600.
Jeez.
100 and 200. 500, what, minus 300 is going to give me 200, and I divide that by 300. That's going to be the one that's like 66.6%. That's 2/3. I know I might be going a little quick over this, but we've done this sort of thing before, right? If I do 600 minus 200 is going to give me 400. I divide that by what, 200? It's going to give me 2. This is going up by what, 200%? So these are my total returns. So which one is doing better on my total returns?
The second account.
Yeah, this guy right here, right? My annual returns. So now I have to go back, look at my formula. It's that A over P. You're the 1 over Y, and then I have to subtract 1. And that is the formula I'm using for my annual returns. Can't believe I got these things memorized now. Taught this class too many times. A over P. If I'm doing 500 and 300 in 4 years, what does my A over P look like?
Five.
500 over
300.
300.
300. Now I'm doing this 1 over Y, which looks like 1 divided by my Y is 4 here.
That's 4 times
And I
10.
have to subtract 1.
Oh. Oh, is that a second one? So 10 is the second one, correct? So you do it again for 10, or how does that?
For this one,
Yeah, it
we
says, it says, so you do it again for the second one too, right?
yeah, we're gonna do this again for the second one. We're not doing that one yet.
Okay.
We're doing, yeah, this one. So I get what, 5/3, which is 1 2/3. So if I do 5/3 to the 0.25, I think is what I'm doing. So if you want to convert this to 0.25, it might help you put it into your calculator. I don't know. But we're doing 5/3 to the 0.25. That should give me like 1.136. And when I subtract 1, I should be getting. See, I'm almost there. All right, is this making sense? I hear this about my answer. This is 13.62. And the other one, now we want to do the other one, A over P. It's going to grow to 600. We started out with 200.
So did you get? So first you said one. Is it 1.1362?
Yeah, and then we subtract 1 from it.
Sorry, I'm going like I'm like seems like I'm doing an echo,
No, you got it. That's it.
but I'm trying to do this while you're talking, so I apologize.
Now we're setting up the other guy. He's going from 200 to 600, and you already told me he was doing that in 10 years. What is 10 years? Professor all the time. I think I could simplify these things a little bit. This is like 3 to the 0.1. Might be easier to put into your calculator than putting that thing in there. 600 divided by 200 is just 3. So if we do 3 to the 0.1 as a decimal power, and then we subtract 1, This is gonna be 1.1161, somewhere in that ballpark, and then I have to subtract one from it.
So do you do that before the minus? So do you do the do you do that before you do -1, or do you do like how did that go? 600, 200, and then the 1/10, and then do you do -1, or do you know? You stop right there.
You do the -1, the very last step.
Oh, -1 is the last step. Okay. You all right, Professor?
Yeah. Man, I don't know what's hitting me. I don't know if I'm getting like mold somewhere. I'm gonna have to scrub down my apartment or something. I don't know. But it didn't hit me till class started, so I don't know. I should just blame y'all, probably, right? Blame it on the math. It's making me allergic.
Oh no.
Okay, so which one had the larger annual return? This guy was the larger annual return, right? And it happened because we did this thing over 4 years and we did this thing over 10 years. So this thing is picking up smaller overall, but larger in the long term, right? All right. So you should be able to put things in monthly expenses. You should be able to do compound interest. You should be able to find returns, annual returns, and total returns. And you have a formula for it, right? So the total returns.
0.11. Then use the 1. Take away is 1161. Okay. You gotta
So the
change it
next
to
one?
the decimal. A decimal. Let's see. Let me see. Did you change this to yeah, you did. Change it to decimal.
Yep, convert it to percentage.
Change it to decimal. All right. So that makes it 1161. Okay. Excellent. All right, I'm in there. All right,
All right. So the next thing is this stock quote. What is the symbol for College Math Corporation? Oh my God! I hope you don't spend too long on that one. It is right there after. That's the ticker, the symbol, whatever they call it.
yeah, I got it.
CMCR. If we want to buy, sell, and trade this thing, that's the thing we're probably going to Google search, look up CMCR. What is the price per share at the end of the day yesterday? So it's
1341
now. And we got to do what?
11, plus 11.
And now the other way around.
Oh, it's negative.
We take away the 11. It went up 11 to get to 1341.
Oh, so when it's a plus, it's really a minus?
It went plus to get to here. Is what happened. Yeah. So we added 11 cents from yesterday to get to 1341. So yeah, if it says plus, you're going to subtract it because it's always doing the opposite of whatever it says. So this would be what, 1330? Based on the current price, what is the total value of the shares that have been traded so far today? So we know they are 1341 per share. That is the current price. And what number am I multiplying this by in that table? I guess that's what you got to know, huh?
The volume?
Volume, which is 31 million. So that is the number of stocks that got traded today. So as I said, I'm not trying to make these things super complicated, like I have, if I'm being honest. I am no expert on reading the stock tickers. There are 4 zeros. And I got what? 175. I think I'm what, at 415,710,000. I'm trying to count the zeros.
415,710. Okay, yeah. Was that 415 million?
Yeah, that's it. What percentage of all CMCR shares have been traded so far today? So what am I doing?
What percentage of college shares have been traded?
This is how many have been traded out of how many?
91,000? Is it 93,200 and, oh no, shares. Oh, I'm sorry. 6954. Is that correct?
That's the total number of shares that exist, and this is the number that have been traded so far today.
Oh,
So if you want the percentage, it's putting what? The number of shares traded today over the total number of shares is what we're doing.
so
So this is 31 million. There's a few ways you can do it, but I think I would just go with the millions and millions. If you want to put all your zeros there, if you want to put 6 zeros behind this 31, you absolutely can.
I like
It would
that
be the
way.
same thing, right?
Let's see, 31.
If you want to put 6 zeros behind here and 6 zeros behind here, you'll get the same number.
Oh, shoot.
But if we know it's all in millions, we can just compare what the 31 million to the 6954 million. As long as they are both in millions, you should be okay dividing those two numbers.
All right. So just the values over one, if it's in the same number bracket, correct? Like if it said thousands, we just use the numbers. All right.
Yeah. If it says thousands, we would have to round to the thousands over here, right? Okay, so if we want this is the decimal that I'm getting. So convert it to percentage. 0.45% maybe. I'm gonna round that up.
0.045. So you round it up. 446. So you beat it.
Mm. Okay, so now we have 150 shares, and based on the current price, we want to know the dividend yield. So if we have 150 shares, let's start with that. How much is our net worth of shares? So we have 150 of them, and each of them are worth 1341. So the first thing you want to do is figure out, like, what's your total value of shares?
Two one.
So I got 201150 in shares. Now, if I want to find out how much of a dividend I'm getting, how do I figure that out from the table? Not this one. I would go with this one. So it's 6.79 is what it tells me my dividend is.
Oh.
And I'm taking that of what number? Probably the thing I just found, right? If we take what, 6.79% of 201150, what is that giving us?
Times 2. Hold on. 5 0 here. 0 1.
36.58.
That's exactly what I'm getting, 136.58. And this is my dividend, right? So maybe box it, let me know this is what I'm getting. So you have to find your total amount in shares. In order to find the dividend, you find the total amount that you have in shares. 150 by the current price is what they're telling us to do it by.
136.
And then after we get how much we have in shares, we just find the percentage of the dividend that we're getting, right? We do that times the percent dividend. What were the earnings per share for CMCR round to the nearest cent? So this is the one that they give it a little bit weird, P to E ratio, right? P to E ratio is 17.41 is what they're giving me in the table. We know one of the things, we know the price of this thing, so we can fill that out. So P is 17.41 divided by E, 17.41. There are a few different ways you could try to figure this out. If you want to put this thing over 1 and figure that out, you can do it. But there's a really kind of cheap trick. is that these two things multiply to this, right? These two things are factors of this thing or whatever. We can look at it kind of the other way. Cheap trick where you can just swap those two numbers, the thing on the bottom with the thing up here. So my earnings should be 13.41 divided by 17.41. So I think my earnings are going to be around
17.41 equals 0.77.
You could put this over 1 and do that cross multiplying thing. You would get the same thing. You will end up with 1341 divided by 17.
So we don't change this. We don't change this percentage, right? Because it's a
No, this is the money amount. This is how much he's earning per share.
okay.
So this is how much they're earning per share. The next question is probably gonna be how much is the whole company earning, right? How much profit did the company earn in the past year? So they earned 0.77 per share. So they're earning 77 cents per share. How many shares did they have?
Oh, is it?
The total number of shares, right?
Yeah, 69.54.
It'd be 69.54.
Is that
And here, maybe I really do want to count for like the fact that it's in millions, right?
so? You
Somehow either putting the zeros in there or saying the word millions, right? Either way, somehow you should probably count times 6954. What does that give me?
so I assume when I'm multiplying, I have to add the zeros, huh?
Yeah, you could probably give it to me in units and in millions, like they say in here with this number. But somehow you have to account for the fact that this is in millions. So I'm just going to go ahead and write out the zeros on this one. So I can write out this whole number basically 535458. And I have 4 zeros.
458. All right. So is that 5 billion?
Yep.
350.
Okay, I feel like we're getting pretty close. We're gonna talk about stocks. Oh, we're gonna talk about loans now, huh? Payments. You want to create a 60K college fund for your kid. You find a savings account with an APR 7%. How much would you have to make in payments in order to save this amount in 18 years? What is the total of all payments that will be made?
Formula is it's a savings plan. Is a savings plan formula? So kind of making payment.
Yep.
Savings plan.
So we want to do the savings plan. So do we want to do the first one where we're solving for the accumulated amount, or do we want to do the second one where it's solving for payment?
We're doing both. As fast, I mean, as cool as you, as smooth as you can.
So are we looking for an accumulated amount, or are we looking for a payment on this problem?
Payment.
We're looking for a payment, so we really want to go with this one.
Gee.
My payment is my accumulated amount, which should give me what, 60K is the
60,000.
I want to do APR over N. So I'm looking at my APR of
7.7.
7% over N, which is monthly.
I'm doing 1 plus. My AP over N is popping up again. This is to the NY, which is to the 12 times the number of years, which is what?
7. I think it was 18 years.
18 years. And then I think I have to subtract one of the other things in this one. So this is the equation I have set up to find my formula. Okay, so if I do 0.07, I divide that by 12, and then I multiply by 60,000. So if I divide and multiply this thing, I should be getting 350 on top.
Times 60,000. Did you get 350?
Yep.
Yep. Yeah.
And this is 0.07 over 12 is going to give me something like 0.00583, somewhere in the ballpark. I got to do 12 times 18 is giving me 216. And I have to track one.
350. Plus 1. This one is clear.
Okay.
0583.
This should be giving me like 3.512, somewhere in that ballpark, and I'm going to subtract 1 from that. So it should be giving me 2.512 on the bottom, somewhere in that ballpark.
This is
All right, just for showing our work, is it okay if we like lay out, like label all of our,
216.
symbols, like what number is going into each one and lay out the formula and then just do the rest in the calculator?
As far as the work here, yeah, I mean, this all kind of depends upon,
Your answer.
yeah, it's like, if you get it wrong, how much of this work are you doing correct then, sort of thing. But this I think is a big part of it, right? If you can get it in this formula right here and get the setup correct, that's going to be probably at least half credit or something like that, And then
Okay.
you'll get like more like getting to the solution might be like the other half of the credit,
Okay.
Professor, I have a question on this one. When I did this, I used the other formula and I still got like the same answer, just like cents off.
If it's a few cents, then that's fine, as long as you're getting within like a couple dollars, right?
Right. Well, I guess my question is like on the test, if we use one formula or the other, as long as we get the same answer, then it's all good, or?
Yeah, as long as you're doing legit math and you're using it, there like you could use the other formula here. You could absolutely use the other formula. It's just like you're gonna have to back solve stuff, right? It's gonna be a little more complicated to get to the solution that you want to. It's just not solved for the right thing. It is the same formula though. So yeah, as long as you're doing good math, like I'm not counting off for good math. So our payment is $139.30. So if we're making this payment, and then I think the other thing they ask is for the total amount in payments made. So if we're making this payment and we're making it monthly for what? 18 years? I'm gonna have to do what? Times 12 times 18 or times 216. We also see that 216 happening up in this problem. So I'm making this 216 times. My total payment should be somewhere around 30,000. Like 80 cents.
So you get 30088.
And so this is my payment. This is my total payment.
I kept messing up because I kept doing 1.00583, and then I'd push that the arrow, and I would put the 216, but it would come out right. It wouldn't come out right.
Okay, so I think we answered both the things that they asked in this question. How much would your payment be? How much would your total payment be? Next question says you decide to save for your child's college funds, so you take advantage of an account described above with 7% APR. You decide that you can afford. You're looking at like 139. You're like, well, I can make a $150 payment. So now you want to make $150 payments. You figure you could probably save up enough doing that. So you can do this you do it for 15 years and then you run out of funds. Pandemic hits or something, I guess. And it's horrible. No, don't go that direction with it. Sensitive topic, probably, right? But we're making these payments, and we're making these payments for 15 years. So what do we want to know? We want to know the amount that's going to be in this account. So we are still doing a savings plan, but guess what we're going to do? Not this one. So we want accumulated amounts. So I think this one is the one that we want to go with. I may not have anything left by the time this class is done. I don't know what it is, man. But it didn't hit me till class started, that's for sure. I guess they'll be scrubbing my apartment pretty soon. You said, okay, so we want to accumulate an amount. What is my payment? That's the first thing I'm putting down. That's the 150 that we're talking about. I'm doing 1 plus on top. My APR over in here, this is still the same thing. It should look very similar to the thing above. I'm doing 7% APR. I'm doing it monthly. I'm doing it monthly for, I couldn't make it for the whole 18 years. I'm going to do this for 15 years, and then I'm going to subtract 1 from this entire thing. Thing is on top. On bottom, it looks like what? 0.07 over 12. My APR over N. So this is 150 if I do APR over N. Give me somewhere in the park of 0.00583. This is going to give me 1.00583. I'm going to raise it to 12 by 15, which is what, 180? Subtract 1. Okay, so I should be getting 1.848. I'm going to subtract 1 and divide it by 0.00583. And then multiply it by 150. All right, so I should be getting somewhere around like 21,842. And I'm getting around 54 cents. Ooh.
Professor, I'm not sure if that's correct.
Okay.
Because $150 times 216 payments is 32,400. Oh, wait. Wait, it wouldn't be 216 payments though. 12 times.
You're doing 180 payments.
Yeah. But still, it would be 27,000 for 180 payments.
What am I off on here? 0.07 over 12. I'm going to add 1. I'm going to do this to the 180. I'm going to subtract 1. I'm going to divide this by 0.07 over 12. And I'm going to multiply that by 150. That's totally off. That's why.
Sorry.
No, you're good. That's totally off. I'm getting 47, 5, 44, 34. Is that what you got? I might have missed a 0 in my 583. 1 point. Oh, what am I?
Yeah, I got that.
One of these
That's why I
numbers
was
is off.
confused. You said 21 something.
Yeah, one of these numbers is off. Let me look at it again. To the 180. 2.848. Oh, this should be 2.848, I think. Sorry. I subtracted the 1 and then I didn't subtract the 1. That's what happened. I ended up subtracting it twice, I think. Does that work? Yes, that's closer. That's what happened. Sorry about that. Go. Yeah, because if we do 150 by 180, that's always a good sort of check. If we're doing 150 by 180, if we're just making direct payments of 150, right, it should be 27K. So this should be compounding. It should be more than just making those payments, right? That's the whole idea of a savings account, is that you're making more than what you're putting in. Okay. 7. In the savings account. How many I got? 9 problems. So we're getting there. Yeah, okay. I was making sure we answered everything on that problem. Okay, making sure it went in multiple parts. That was it. You need a home loan of 150K. The bank offers 2 loan options. One is 30 years with 5% APR. Second is 10 years with 4.3 APR. Compare your monthly and total loan cost for the 2 options. Okay, so we don't have too many more formulas left, but guess which one you're using on this one? What sort of thing are we doing?
Loan payment?
It's got to be the loan repayment formula. So we're pulling off of this loan repayment formula. Yeah, whew. We want to use our loan repayment formula. My principal, the thing that I want to save for, is the 150K. I want to do my principal times my APR over N. So I have 2 different things I want to do. I have a 30-year loan that I want to figure out first. So I want to do the 30-year first, and then after I do the 30-year, I'll do the 10-year, right? But for my 30-year, my APR is 5%. And we're doing that monthly. So this looks like P times APR over N. On the bottom is the funky stuff that looks like 1 minus 1 plus. My AP over n looks like 0.05 over 12. And I'm doing this to the negative n times y, which is here I'm doing for 30 years. Okay, so what am I doing? 0.05 over 12,
Professor, why did you make it a -12?
because that's what's in the formula.
Oh,
Yeah, there's a negative in the formula itself, right? I'm doing 0.05 over 12, and then I gotta multiply 150K. All right, 150, 1, 2, 3. 625, I think, is what I'm getting on top. On bottom, it looks like 1 minus 1 plus 0.05 over 12. I've rounded its point. Ballpark. And I'm doing 12 times 3 would be minus 360. All right, so when we multiply this, well, not multiply, when we raise this to exponents, 1.004167 and raise that to the negative 360. So I don't know if your calculator is like mine, but like it does distinguish between putting like the negative sign in there, or the negative sign, which is this one, and the subtraction sign. So if it's a negative exponent, you actually have to push the negative sign versus the subtraction sign. Odd distinction, but it makes it for some reason. 0.2238 is the ballpark, somewhere in that ballpark. I'm doing 1 minus that amount. Gives me somewhere like 0.7762. Phew.
Gesundheit type.
And I'm taking 625 and dividing it by that number. I should be getting a payment of somewhere around 805.23. And this is for a 30-year loan. So if I want to know how much I'm making in total payments, this is my monthly payment. I got to do this what? By month, by year. So by the number of months, by 12, and by the number of years, which is what, 30?
23 times 12. Again, times 20 minutes,
By 360 is another way to do it.
30 years.
289,883.
Yeah.
And what? 67.16 cents if you round it up.
289.
This is the total, right? Total payment.
So, Professor, is it safe to say that even if I'm doing percentages, or I'm doing the decimal, like now, money, currency, whatever,
Mhm.
that only count as far as the 10th, the 100th place. You know, when you're like,
If you're doing money, yeah, you're gonna go to two
because in
decimal
the
places.
computer it just says 289888368. It doesn't do that. You know, it doesn't do money conversion. It doesn't turn it into money. It just says 289888368. So 0.68. So
Yeah, if you're doing money, you usually round it to like the nearest cent, the two
Okay.
decimal places.
all right.
I usually try to grab at least 2 or 3 decimal places in whatever I'm doing.
All right.
At least by the answer is what I try to do, like 2 or 3. Okay, so I think that is my 30-year loan. They give me another option of what, a 9-year loan?
10-year.
No, it's a 10-year loan. Yeah. So how does my 10-year loan differ? Comparing and contrasting these things might help. And what, my payment or my principal is still going to be the same. My 10-year APR is going to be different. Instead of 5%, it's what, 4.3?
Yeah.
So make sure you convert your percentages to decimals correctly. That's something people mess up on sometimes. They'll forget to put the 0 in there or something like that and say 0.43. No, that's 43%, not 4. And it looks similar on the bottom. 0.5, I have my 0.04. 12. And now this is the minus 12 times. Now my number of years is changing to
It's 12 times 10. Okay.
all right, so clean this up a little bit, 0.043 over 12. And then we what, multiply by 150K. I'm getting 537.5 on top. 0.043 divided by 12 plus 1. This thing is somewhere in the ballpark of 1.003583. And now I have to raise this to the minus 12 times 10 gives me minus 120. So if I want to do these crazy exponents, that's probably the next thing I'm going to do. 1 minus, and now I'm doing these crazy exponents. This is giving me somewhere in the ballpark of 0.651 in that area. Then I got to subtract 1 from that. 537 over something like 0.34899. Getting 50, 40, 15. We're probably going to round it on up to the nearest cent at 16.
38538 5 537.
And this is the monthly payment.
899.
And so the other thing we have to do, so this is 1540.60 times the number of months, which is 12, times the number of years here, which was 10. Or you could just do 1540.16 times what, 120? We'll get you there too. 184,818.66.
1540. Okay, I hit 154037. So I'm off a little bit.
37, that's 20 cents off. That's not bad. Yeah,
So
that's rounding.
Times
Okay.
12 times 10.
Did I do that right? I did that wrong, didn't I? 15, 4, 16. Say 16. I don't know. I said 16. How does that compare to the other thing we just found?
148. So was that? Is it? Jesus.
So it looks like
So
your
Professor, I
payments.
got 184844.4. Is that correct?
184. What'd you say?
184,844.
That's close enough. You're like,
184,844.4.
yeah, you're like $30 off on something that's 180,000. It's not too bad.
Okay. So, Jesus.
So if we look at what 1540 versus 800, this payment's about like half as much. But over the course of the loan's going to cost you about twice as much, right? It's going to cost you 100,000 more, basically. If we look at the total cost, this one is definitely cheaper, right? Even though the payment is more. So if we're comparing payments, we're comparing total costs. This payment's cheaper, but the total cost is more. This payment's more, but the total cost is cheaper because we're doing it for a shorter period of time. Okay, and then we're gonna have a scenario. Suppose that you chose, it is 2:35 right now. If you got to get somewhere, you can go ahead and get somewhere. I'm gonna finish off this 1.5 problems we got left on this review. Suppose that you chose to go with the 30-year loan with 5% from the example above, but you want to pay it off in 10 years. How much are the monthly payments and total cost of this option? So this, we had something similar in the notes. Like, so this gives you a little bit of buffer, right, is what it does. So now we're going 10 years and we're doing 10 years on the 30-year loan. So we want to take all the information from the 30-year loan and find the payments. Like I took the previous two formulas and combined them together in some weird way and created a baby out of them. But is 150K is still the principal here. My APR now is 5% because I'm taking the 30 option. I'm doing it monthly. The 1 minus 1 plus create anything on the bottom. I'm doing 5 over 12. I'm doing this n times
Negative 12 times. Are we doing back over again the same thing? The 10?
10. So now we're changing the interest rate here, right? We're changing it to the 30% rate to see how it's going to change it a little bit. I think I'm still getting 625 on top. That should give me the same number that I got previously. We're not changing that.
Sure did.
So that one should still be the same.
One.
This one's going to change a little bit because we changed the years, right? We changed the percent. So 5 over 12. We're going to add 1. So this is 1 minus 1.004167. Somewhere in that ballpark. 120 power. All in the denominator.
So this was negative 120. Well, I got 120.5. What is that about?
I don't know what you're doing there. 12 and 10 are 120.
Oh, you know what? I put the 1 minus in there. I shouldn't have.
625 over 1 minus.
Yeah.
And if I raise this entire thing to the negative 120, it's giving me 60716, somewhere in this ballpark is what the calculator's giving me. I'm doing 1 minus this amount. I should have 625 over 0.39283, somewhere in that ballpark. 6 625, and I'm dividing it by this thing. My new payments on this thing should be 1590.98.
Yeah. So that
And this is my monthly. If I want to know my total, I have to go by what? By 12 by 10, I believe.
Professor, you said okay, so why is my okay, wait a minute. Damn it.
199.17. And 93 cents, I think.
I almost going to say
Total. So how does this compare? It's probably more than the other one. I already threw them all in that. It's probably way more than what?
Did you get, Professor, what was your answer?
Or which one? This one?
Yeah. What did you get?
Monthly was
Yeah,
159.
1909176. Okay, so I got 190917.6. That's crazy. So how I don't know what I did.
On which one? The monthly or the total?
The total.
The total, if you're getting around 190 and 91, that's close enough. Like you're getting within the dollar. Like that's good enough. You're just if it's off, it's off by rounding at this point. If you're getting that close,
All right.
and it's not, that's fine. Monthly and total cost of the year loan option. We're done with that. The last thing I want you to do is a little bit of taxes. So I got a little bit of tax problem. I got wages of 105.2356, and I got 33.48.13 in interest from a savings account. Contribute 1381 to tax deferred retirement plan. Entitled to the exemption and deduction that they say there. Determine our gross income, adjusted gross income, and taxable. So gross is everything that you're taking in. It's the nasty big number of adding everything. 105 gross. 48.13. So I want to add these two numbers to get my gross income.
Mm.
813.
One 105,579.6.
69. Yeah, that should be it. We're adding these two things together to get our gross income. Adjusted gross income, we take off adjustments like tax deferred savings plans, things along those lines. 105,579.69. And we're taking off our tax deferred 1381.72. Minus 1381.72. Now I'm getting what? 104.197.97. And then the last thing I want to find is my taxable income. So if I want my taxable, I'm starting with the 104.197.97 and taking off my standard exemptions and deductions. It doesn't say.
So what is it? 10497.97.
I should have said she's taking a single. She's a single with no dependents. I probably really should have said that. But if it doesn't say they have any dependents and it doesn't say they are married or anything like that, I guess we could kind of probably assume they're single, especially since the next thing that they're giving us is the single bracket, right? So if we're taking off 3,900 and we're taking off 6,100, 941 94, 197, 97. Where I'm at.
4, 7, 6. Well, clear.
So the next thing is basically going to tell us use the following table to find the marginal tax rates. So we have to find marginal taxes in this at some point. And then they tell us the amount that she paid already. And so we get to subtract the amount paid. But the first thing is to find marginal taxes. So if she's making 94K, we're going past this, we're going past this. Do we go past 87?
Yes.
Yes.
So we should be going into here. Do we go past 183? We
No.
are
No.
not going past here. So it should fall into here. So this right here, I'm hoping you're looking. I should be writing 4 different brackets, right?
Jesus. So we write all 4 of those numbers down?
Well, the first thing, I'm taking 12% on the first, how much?
8,925.
89.25. If you want to do like subtract 0 to get that pattern down, you can. It's not really going to do anything. But from 0 to 8925, we're taking 12%.
Oh,
We're taking 5% on. We're starting at 8925 when we're going up to
0.175.
what number are we going up to in the 17?
36.
The
So-
36. So we're going up to 36,250 when we started at 8925.
Yeah. That's again.
So we have to subtract those two.
We changed that. So we got, oh, you got to do 2 of them first and then do the other 2?
Yeah, and then now we're doing what? Plus 0.28. I'm continuing on. I'm in the 28% bracket. I do the same thing up to what? 87,850 is what this one goes up to. And I have to subtract what number now?
36,250.
Yeah, the 36,250 that we left off of in the previous bracket. And there's one more bracket. I'm running out a little bit of room here, but I'm doing the 35% bracket. And now what amount do I go up to? So this is the one where you might have to be a little careful.
Is it
The
the 94,000? Yeah.
197.
Yeah, we can only tax as much as this guy. Okay. So 8925, I'm probably going to do the subtraction and the multiplication all together. From my first tax bracket, I should be getting charged what, 1071 when I do 12% of 8925. When I do 17.5% of 36,250 minus 8925, I should be getting taxed 4781. And I'm probably not going to round things to the
Is that a negative O?
yeah, mine is 0. It's not doing anything. We're going from 0 to 8925.
Oh,
You really don't have to put it there. I just like it because it gives the pattern from 0 to 8925, right? It gives you your brackets all in here from 0 to 8925, from 8925 to 36,250. And what I'm doing 28% of 87850 minus what 36,250
1, 2, 8.
gives me 14,448 plus 14. Now my 35% bracket. If I do 35% of 94,197.97, and I subtract 878.50. 2221.7895. I think is what I'm doing. And so now I am adding all these things together.
Right here. So that I got 24,084.53. Is that right?
So if I add these 4 things together,
Yeah.
is that what you're doing? I should be getting something like 22522.
Ah, what the hell? Oh, you know, I did the whole equation.
Point what? 66.
I got 24084. I probably did the whole equation. I shouldn't have done the whole equation. Maybe I was supposed to do like the first three and then use that number, or just do one number at a time.
So I'm not sure what you're asking, but like what we have to do is
Like
we have
I did the whole bracket. I did all the brackets together. So in other words, I just do the bracket, the 12 times 8925,
Yep.
and then get that number, and then do the same thing, get that number, correct? With the other 175 times 36250, and then get that number. So each one is done to get to use that number. Okay, and then you add those together. Got it. Okay. I'm getting it.
Yes, I'm getting that 4781.875 by subtracting these two things and multiplying, right?
Right.
Yeah, so you're subtracting the brackets and then you're multiplying by the percentage. I'm doing 2 steps in one, probably in this one. And in this step, I'm adding 4 numbers together. So I'm adding these 4 brackets together. I should be getting what? 222, 522, 66. And this is the amount that should be collected from my taxes. This is the amount that I am owing.
For these, when we get to what we owe after we do all of our calculations, we should just be rounding up to the nearest dollar amount, right?
Yeah, you should, yeah, I'm rounding to the nearest cent. If you round to the nearest dollar, that's probably pretty fine.
Okay.
And so I have this is the amount that I'm getting taxed. This is the amount that I owe. But I've already paid what, 8956.78. So I got to take out the amount that they withheld from my paycheck. So if they withheld what, 95678. 95678. So I'm still taking this amount off. I've paid that amount already. So minus 89. Nope. 22,522.66. And I'm taking out 8956 and what, 78 cents. And so we still owe what, 13K, somewhere around there.
Jesus.
Okay, so this came out to be a positive amount. If I paid more than what I owe, then this wouldn't be a what? This wouldn't be the amount that I have. This would be a refund, right? So if I get a negative amount, I'm getting a refund. So if you get a negative amount, you should probably say this is a refund at some point. So you get a refund of this amount, or you owe this amount, right? All right, but that is the final thing you should be able to do before you can take this test, is to do these marginal tax brackets, right? Probably the last sort of like difficult concept, right? Get down.
Thank you.
All right, that's it.
Have a good one.
Y'all got any questions? I'll be around. I'm gonna stop.